Hi guys, Miss Urrego here. A couple of things. We just finished factoring. Now the whole idea is to solve by factoring. If you notice here my title, learning targets, students will be able to solve quadratic expressions by factoring. And we're going to introduce what is called the zero product property. Our vocabulary stays the same: greatest common factor, solutions of the function. Now these two words are brand new. These two terms. Solution and solutions of the function. So the whole idea when we use the zero product property is that we find the values of x. We'll do that in a minute. Now, my build work is a factor completely. I have a binomial. Remember, the first thing you always check is to see if you have a greatest common factor. And I'm using it right now, greatest common factor. So we have 3x squared minus 18x. You always check to see the numbers, if there's any common factor between the two numbers right there. Okay, so I have let me see, I have the 3 and I have the 18. Okay, I normally tell my students to see, tell them if the to check if the smallest number goes into the bigger number. Is 3 into the 18? Yeah, 6 times, right? So because 3 is into the 18, then 3 is going to be my common factor. Now let me just write it down just in case. So 3 is the same as 3 times 1, and 18 is the same as 3 times 6. So as you can see, we have a common factor of 3. So therefore, I got a 3 is common factor. Then I check if the variables to see if the variable is a common factor. Yes, it is. So I choose the one with the lowest exponent. So it's going to be my 3x. Okay? After that is a matter of just opening my parentheses and start dividing. So now what I'm going to do is I'm going to divide every term. I'm going to divide every single term divided by my common factor. Okay, my answer is going to go on the inside. So let's see how that works. Now to make it easier, what I'm doing lately is my right there, my term, I put my common factor underneath, my term, common factor underneath. And then I put the answer underneath, and to make it easier, I guess. So now I have my first term, okay, my first term, which is going to be 3x squared divided by 3x. The 3 divided by 3 cancel out. And then I have x squared. When I'm dividing those variables, I keep the same variable, and I subtract the exponents. I have a 2 on the top, and there's nothing here, so I have a 1. So 2 minus 1 is 1. And that answer goes inside the parentheses. Next, I kind of erase it, but you have a minus right there. So I'm going to write it again. So minus goes on the inside. And now the second one, 18 divided by 6. 18 divided by 3 gives me 6. X with x, they cancel out. So that 6 goes on the inside. All right. And that's pretty much it. Okay, I'm factoring. I did GCF only right there. Now I have problem number 2. It says 9x squared minus 1. So 9x squared minus 1. The first thing I check is GCF. I check to see if I have a greatest common factor between the two of them. I have a coefficient of 9 at the beginning. I have a 1 at the end. So technically, if I see only a 1, then there's no GCF. It's only 1, so I don't want to go there. I will do GCF if there's a number different to 1. If it's 1, that's it, no GCF. I check that the variable. The variable is here, but there's no variable in the second one. Therefore, I have no GCF. So straightforward. How many terms I have here? 1 and 2. So I have to use difference of squares. To use difference of squares, I'm going to take the square root of the first one, which is 9x squared. Square root of 9 is 3. Square root of x squared is x. And when I'm factoring difference of squares, what's going to happen is I'm going to open 2 parentheses. I did the square root of the first one, so that goes in the beginning. 3x and 3x. That goes in the beginning of each parenthesis. Then my difference of squares, I'm going to use plus or minus. Every time I factor difference of squares, one of our parentheses is going to have a plus and the other one has a minus. It doesn't matter the order. I normally do plus and minus, all right, on my 2 parentheses. And the last thing to do is you take the second term and you do square root of 1. which is 1. And that goes at the end of each binomial. And you're pretty much done with that. And that's how you factor difference of squares. Now, but the whole idea with today's lesson is to introduce what is called the zero product property. Okay? And basically is you have 3 terms right here. You got one term, A, B times C, 3 terms. And they're saying that that equals to 0. So that means that every single factor, A is a factor, B is a factor, and C is a factor because all of them are multiplying each other. And when they're multiplying, now they're called factors. Okay, so A is a factor, B is a factor, and C is a factor. The whole idea with the zero product property is we equal to 0. And from there, we are told that every factor could be 0. Okay? Now, that goes straight into one of the examples. And the original example that this came from is when they say solve, and I want to do it a different color. The original example, they just explain here just how to apply the zero product property. But first, basically, is you're going to have a problem like this, like what I did right here on purple. Okay, and they're going to ask you, solve that equation or function. Equation, basically, not a function. So solve that equation. And you're going to have x squared plus 2x equals 0. The whole idea is to find the values of x. What values of x satisfy that equality, that equation? Okay, how do we do that? That's where we learn factoring first. So I got 2 terms here. Therefore, I need to see if that's a trinomial, difference of squares, or greatest common factor. I always apply greatest common factor first, and then I notice that the x is common. I choose the one with the lowest exponent. After that, I put a parenthesis because there's no numbers as a common factor. There's only 1 here and a 2 there. If there's a 1, I don't take it as a common factor. Now, x squared divided by x goes on the inside, x plus, and then I take the 2x divided by x, and that's going to give me a 2. Equals to 0. Now, the zero product property basically is telling me that every single factor that I have to make it equal to 0. Now, I notice that the x is multiplying the x plus 2. The whole parenthesis is one factor, and the x is another factor. So every single factor has to be equal to 0. And that's what they do here. If you notice, they have here x, parenthesis x plus 2 equals 0. From there, they make the first x, which is one factor, equals to 0. And then they take the parenthesis, which is the second factor, and make it equal to 0. From there, you got to find the value of x. Being that the first one is already equal to 0, then x equals 0. And the second one, you have x plus 2 equals 0. From there, leaving the x by itself. And I'm going to put it here on the left side. What they did is they subtracted 2 on this side and 2 on the other side. On the left side, 2 minus 2 cancels out, get 0. So you get x equals 0 minus 2 is negative 2. And that's how they got the second answer. So basically, when you're applying the zero product property is you make it equal to 0, and every factor you have to make it equal to 0 and find the value of x. Let me explain you with a couple more examples. To help us with time, basically, I use the same example that I had on the board in my bell work, which was 3x squared minus 18x, and I said just factor. In my case right now, I'm saying solve. I'm not saying factor anymore. I'm saying solve. And I'm saying solve it by factoring. That means your first step has to be factoring. So now we understand that this is a GCF problem, and then my 3x was a common factor. And my inside was 3x divided by x, was x, minus 18x divided by 3x. That's going to give me 6. Okay, you notice the difference now is that I have equal to 0. I have an equation equal to 0 or any number, okay? But now, whenever we're solving, we have to be careful because we need to have equal to 0 anytime we're going to factor or solve. In this example, my expression was already equal to 0, so we're ready to go. Now let's get back to the problem. I factor using the GCF. I'm done with that. Excellent. Now, because there's nothing else that I can do, I identify my factors. My 3x is one factor, and the x minus 6 is another factor. So what I have to do with those two factors is that every single factor, what I normally do is I make a line between the factors, and I say, all right, my first factor has to be equal to 0, and the second factor, which is x minus 6, has to be equal to 0. Please find the values of x. To leave the x by itself here, I got to divide by 3 and by 3. That gives me 0 divided by 3, which is 0, and that gives me the first value of x. The second value of x is I have x minus 6 equals 0, so to get rid of that 6, I need to do the opposite, which is plus 6, plus 6. The 6 is cancelled, and now I have x equals 0 plus 6 is 6. And I had my two answers. If we want to double check if our answers are right or wrong, then what we have to do is we have to bring back our original expression, which is original equation equals 0. And then I have to plug in each of these values. I have to get here the x equals 0, and replace it here where the x is. So instead of the x squared and the x, I'm going to replace it by 0. So that's the whole idea. So what I'm going to do is I'm going to take a 3, and instead of the x squared, I'm going to put 0 to the second power minus 18 times x, but in this case is 0, equals to 0. 0 to the second power, I'm working here, is 0 times 3 is 0, minus 18 times 0, anything times 0 is 0, and 0 is equal to 0, so that means my first value is right. We got to do the same process with the 6. Okay? So instead of the x squared, replace the 6, and we go from there. Now, I'm going to leave that one for you to check. Okay? It's the same thing, and at the end, you're going to have 0 equals to 0. Now, let's proceed to another example. I have 9x squared minus 1 equals to 0. If you remember in the beginning of the video, my Bell work didn't have an equal to 0. My Bell work was just factor. Okay, let me go back to my Bell work. Here, my Bell work, my example, 9x squared minus 1, there is no equal to sign. So when this happens, the equation is going to be factor. Okay, there's no equal whatsoever. But if I have my expression equal to 0 or equal to any other value, okay, equal to 0 in this case, then that means I have to solve. So my question will be solve, okay, which means find the values of x. So let's proceed to do this. Now, first thing I have to do is GCF, difference of squares, trinomials. This is my difference of squares, which we factor at the top. My answer for that difference of squares was 3x plus 1, 3x minus 1. Equals, I got to bring that down to 0, equal to 0. How many factors I have? You need to identify that. I have two parentheses that are multiplying each other, so I have two factors, which means that every parenthesis or every factor, it has to be equal to 0. There's 0. My other factor equals to 0. And from there, you just have to leave the x by itself. So my first over here will be, I'll be subtracting minus 1 on both sides. This one's cancelled. 3x equals negative 1. Last step, divided by 3, divided by 3. Therefore, my x is going to be equal to negative 1 over 3. And I have my first answer. Same process with the second one. I got 3x minus 1 equals 0. Then that means I have to plus 1, those cancel. 3x equals 1 divided by 3 on both sides. X equals 1/3. So those are my two answers. Again, if you plug those values back on the original equation, then they should cancel each other and the answer should be equal to 0. Okay, guys, so I think that's it for solving. Basically, anytime you're solving, it's the same process. You factor first, and then you make your factors equal to 0, find the values of x, and you're done. That'll be your answer. Now, you can write your answers like that, or you can write your answers in braces, which many textbooks will have the answers written with braces. So my first answer is the lowest one, which is negative 1/3, comma. The bigger one is 1/3, close braces. Okay, so you can show them like that on braces, or you can show your answers with the X's. Either one of them. All right, guys, take care. Have fun and study, please. Bye.